Hi, I'm recording this video for my GCSE Electronics and A-level electronics students who might be considering making some sort of vehicle safety system. When I say vehicle safety system, what I'm talking about here, and this, by the way, it could be applied to any vehicle. What's this? I suppose it's a front loader with a backhoe or back grab or something like that. But in many such commercial vehicles, you're going to get some sort of warning when you reach a certain, or getting close to a threshold and you're about to tip over. Maybe there's even some sort of on-screen in-cab indicator showing you how far you're tipping over, a little bit like an artificial horizon in an aircraft, but you can imagine the sort of thing. Now, I suppose you could apply this sort of vehicle safety system not just to land-based vehicles, but to boats, aircraft, whatever, okay? So what we're going to do in this video, have a quick look at a possible system block diagram, just identify a few of the inputs, processes and outputs that might be of interest. I'm not giving you a solution to a particular problem here, so if you're considering doing something like this yourself, it's trying to inspire ideas and trying to generate some thoughts for you, okay? Right, okay, so first of all, you need to identify what the actual problem is. So if you haven't done so already, you need to identify whether you just want an indication of like how far you're tipping over, or what the angle is, or whether you want a threshold warning and you don't need any indication of the angle of inclination. So that would be the first thing you need to do. Let's say that we want to have sort of like a bit of an all singing, all dancing system. Maybe you actually want to have some sort of indication of the degree of tip, and also have some sort of threshold alarms and things like that. So now, if it's a GCSE project, if you were doing something like that, you probably want to cut it down and make it as narrow and as simple as possible, because you don't want to make it too difficult for yourself. A level, yeah, you can go a little bit further. But whatever the level is, you're going to have inputs, processes and outputs, and I would say almost certainly with a project like this, you're going to find it a lot easier to have a microcontroller at the heart of your system, because then you can well, there's an awful lot you can do with very little wiring basically, okay? And particularly for GCSE, you can do this on a Genie microcontroller and it's relatively a piece of cake. So let's say that we're going to have some sort of safety system. Let's do the stuff that we know first. So we're going to do a safety system, and it should warn us when maybe we're about to tip over, or just before we're about to tip over, or something like that. We're going to need an audible alert, presumably, and we're going to need maybe a visual alert. Okay, so they're going to be outputs. We know they're outputs. Now, if it's a loud audible alert, let's say maybe like loudspeaker driven, then you can't drive the loudspeaker directly from a microcontroller, so you might need a transducer driver. Now at this early initial stage of planning, you might just want to say audible alert rather than write loudspeaker, because loudspeakers are actually going to make it a little bit more work for you than say a buzzer would. A buzzer would connect directly to the microcontroller. So if you are annotating your system block diagram, probably be a good idea to say, like transducer driver if needed, or optional, or whatever it happens to be. I mean, the audible alert, you might like to add a note here that it could be a loudspeaker, in which case we need a transducer driver. If it's a buzzer, it should be able to drive it directly. So you can add some notes onto this as well. Or elsewhere, you can do the discussion, you could say something along the lines of, I've identified that I'm going to need an audible and visual alert. The visual alert could take the form of, and then you talk about those things, and the same with the audible alert as well. And maybe you can talk about the pros and cons of maybe having a buzzer versus a loudspeaker, or lamps versus LEDs, or whatever it happens to be. Now, it would probably be quite a good idea to identify what sort of outputs you want, because if, say, for example, you want to know the actual angle of inclination in the output, then that is something you're going to need to sense on the input. So I'd probably be thinking first what I want out of it, and then identify what I need into it, rather than specifying the inputs and then realizing you can't get out of your system what you want. Now, for this sort of system, the easiest thing by far would just be like maybe progressive LEDs. So and maybe, I mean, do you even need the direction? Maybe you're only going to have like the degree of inclination. So for example, you could have like a bank of LEDs like that, and then when the first one lights up, that just means like you're slightly tilted over, maybe left or right, doesn't matter. And maybe when 2 light up, then you're even more, and then when you're like 3 lit up, and maybe you can have like a fourth one, and maybe that can be red or something, so you know, slightly more sort of warning like, and then that's the thing which is saying you're about to tip over. Now, do you actually need to show the direction which you're about to tip over on? Because it's probably going to be fairly evident to most people. I would suggest probably not, but there might be a reason that you want to have that. Maybe, I don't know, maybe you're doing this for, well, it wouldn't be astronauts, but maybe, I don't know, a fighter pilot or something, which he may have completely, or she may have completely lost track of whether they're banking right or left or whatever, okay? I can't think that's actually going to be useful, but yeah, possibly. If you wanted to have like the severity of the banking, and then you also want a left and right, maybe the left and right could be indicated by, you know, like 2 LEDs. And so this one, if this one illuminates, you're banking over to the left. If this one, then banking over to the right. So that's a possible way of doing the indicators. Of course, you could have some sort of analog dial with a needle pointing over. That's going to get quite difficult to control with a microcontroller, so I'd probably avoid that one, okay, certainly for a GCSE project. There are other options. What we could do, we could have, say, in this indicator, we could actually have an LCD display which could then output the angle of inclination. But having said that, when you actually do the sensing of the angle, you know, how accurate are you actually going to be? You're not going to measure to like the nearest degree. Probably more likely you'll be measuring, I don't know, say in 10-degree increments or something. You'd have to have a think about that. So do you actually really need an LCD display giving you what looks apparently like precise information but not? That's something that you're going to need to decide upon. Right, okay, so once you've decided really what you want to get out of the system, then you need to go to the inputs and then think, okay, how do I need to sense that? If all you want to do is to sense whether it's tilted over to the dangerous extreme on the right or the dangerous extreme on the left, maybe you could just manage with 2 tilt sensors. And a tilt sensor can, I mean, I'm sure there's lots of different ones, but it could look like a little metal can. And in the metal can, there's 2 wires going in there, and there's a steel ball or a metal ball in there anyway. When it's tilted over, the ball goes onto the 2 wires there, therefore completing the circuit so the current can flow. Okay, so you could have just, basically they're just switches, okay? So you could, oh, by the way, in the past we used to have mercury, but yeah, it's too dangerous, so we don't use mercury now. So you could have like 2 of these sensors. In fact, you could have more than 2. You could have multiple ones set at different angles, and then so when progressively you are leaning over, then the switch is closed, so, or open, whichever way around you've oriented the switches. So that's a possibility. The other thing you could have for banking sensor or tilt sensor, you could have a potentiometer, and I'm just looking around to see if I've got any handy potentiometers, not directly in front of me, but something where you twist and it's going to be a variable resistor, and then the way that you can use that is then you can take an analog value from that. You'd probably get it configured as a potential divider, so and it would actually look something like, and it's going to have 3 legs. Okay, these are the 3 legs or pins, and so your power is connected to these, like be positive power, the ground, and then this will be the analog output voltage, because effectively it works as a potential divider. And then you take this voltage here, and then that goes into the microcontroller, assuming you want to have the analog value that goes into the microcontroller, and then you can take an analog reading and then do some processing on that. The alternative, actually, if you wanted just to do thresholds, so you didn't want the analog value to be processed by the microcontroller, you could use a comparator. So when the analog value meets a certain level, then you could then output a digital logic high or low, which could then be fed into the microcontroller. So there's different ways. Okay, so you could use like tilt switches, you could use a potentiometer, which is basically like a variable resistor, and other ways you can have encoded discs. Now, encoded discs are the thing to do for this sort of application, and the encoded disc is going to have like lots of segments, and then it's going to have maybe, it depends on what precision you want, but there's going to be like various bits shaded in. Now, the thing that you need to look up if you're interested in this is Gray, Gray, okay, I think that must be the person's name, Gray encoding. I think it's Gray encoding or Gray coding, I'm not too sure. I'm gonna guess at Gray encoding, but it might be Gray coding. And then you'll have sensors representing each of these tracks, so you have sensors going over each of these and then reading the zeros and ones effectively off this. Then you can work out which way this is oriented, and yeah, so then this whole disk, or maybe the sensors, are going to swing as the vehicle swings over like that. Most times when you do something like this, you're probably going to use an infrared emitter to emit light that goes onto this disk, and then you'll have an infrared detector to detect whether that's logic 0 or 1. Sometimes it's a little bit noisy, it's not a very definite pulse 0 or 1, so you can go from if you're going to use Gray encoding, you probably have the sensor, and then you have something called a Schmidt trigger. A-level students will know what I'm talking about. GCSE would have to discuss that further, but a Schmidt trigger could process the signal. Now, maybe you're driving on a bank all day or something, and you just have to go a little bit closer than you want, or maybe you're doing an operation in your aeroplane and you're doing heavy banking, whatever, and so you don't want that warning. Maybe you need some sort of mute warning input or something like that, and maybe activate and deactivate as well. Maybe that's another option. Maybe you just don't want to have the system running at all. So there's going to be other things that you can have for sure. I'm sure there would be. That's probably most of the things that I can think of just off the top of my head for the moment. But so just to recap then, if you're thinking about vehicle safety, what is the problem? Do you want to be notified like how far you're going over, or do you want to be notified only when you're about to tip over, or progressively, or whatever? Do you need to know whether the angle is do you need to know the angle? And then also, do you need to then, if you need to have the angle reported to you, do you need to know whether it's right or left, or just the angle? What sort of alerts do you want? What sort of method then, knowing all of this, could you use to detect the banking, the inclination, the angle, whatever you want to call it? Okay, and then what other additional features might you have? Finally, GCSE students, no, keep it as simple as you can. So there's a lot of stuff going on here. So for example, if you decide that you were to go for Gray encoding, just be aware that you're going to have Gray encoding, which is going to be challenging in itself. And then you're going to have Schmidt triggers probably, and then because this has given you lots of data to process, do you really then want to give a lot of data out? But that might be unnecessarily complex, and maybe you might then think, well, I'm going to do that bit that's quite complex, so I'm going to make the output easy to implement, say with using an LCD display, but still giving all the information that you could get from there. Okay, so GCSE students, do remember, don't make your lives too difficult. You're not going to thank yourself for getting a difficult project, believe me. Okay. That was 15 minutes, rather too long I suspect, but if you found it useful, please give it the thumbs up. Okay, thanks.